Today we're going to be talking about a nephron, and the nephron is the functional unit of the kidney, meaning that's the important part of the kidney that does all the work. And what is the work? Well, the work is filtering nitrogenous wastes such as ammonia, urea, uric acid. In humans, that's mainly urea. Maintaining pH, maintaining blood pressure, maintaining electrolyte balance. All those things are performed by a tiny little nephron that's microscopic. However, collectively, and there's about 1 million of these nephrons per kidney, collectively these little tiny nephrons do an incredible amount of work. Let's go ahead and take a look at a model of the kidney. So here's a model of the kidney. And you can see that there's an outer region called a cortex and an inner region called a medulla. So you got the renal cortex and the renal medulla. And right at the junction, the cortical medullary junction, is where you're going to find the majority of these little nephrons. About 1 million per kidney. You've also got some blood vessels here. You've got a renal artery in red here entering the kidney, and that comes right off the aorta. So this kidney gets a huge amount of blood each day. After that blood is processed by the nephrons, it is returned through the renal vein, which then connects to the inferior vena cava and goes to the right side of the heart. We also have a ureter here, and this ureter collects the urine produced by all these tiny little nephrons. This ureter then goes to the urinary bladder where urine is stored temporarily and then exits via the urethra from the body. Let's go ahead and draw a simplified diagram of a nephron, since it is the functional unit of the kidney. So there's a simplified diagram of a nephron. And a nephron is simply a hollow pipe, just like your digestive canal. However, just like the digestive canal, each section is going to be very specialized, just like an assembly line. Each section does a very special job. And we're going to go through each one of those jobs until finally the urine is finished and then exits the body. Well, let's go ahead and draw one more thing. I need to draw the blood vessels coming in here. So here's a blood vessel coming in from the renal artery. It comes in. We're going to have a huge knot of capillaries. And then we're going to exit, come over here, down around this big tube, over, and eventually leave. Now don't just think that there's one capillary per nephron. There's actually an entire capillary network. But remember, this is a simplified diagram. Now up here, this is going to be a capillary coming from the renal artery. So let's write from renal artery. And the blood's flowing in that direction. And the blood flows into this big knot of capillaries. And this huge knot of capillaries is going to be referred to as the glomerulus. So it's a bunch of capillaries. And this glomerulus is responsible for filtration. That's its job, filter the blood. This knot of capillaries actually has little holes in it, called fenestrations. And these little holes allow parts of the blood to actually leave and be filtered. Now, these holes are a certain size, so not everything can leave the glomerulus. Only things that are smaller than those holes. Anything bigger than the holes can't leave. So what can't leave? These things can't leave. Blood cells, all right? Can't leave. And proteins can't leave. So let's just write that down. These things can't leave. Everything else pretty much can leave. Now, when it leaves, these things go into this hollow tubule right here called Bowman's capsule. Now, this is Bowman's capsule right here, and after the blood is filtered, the stuff that actually goes into Bowman's capsule is referred to as filtrate. Filtrate is the stuff that actually passes through the filter. So we've got a bunch of filtrate in here. And what does the filtrate actually contain? Well, let's write that down. I'm going to write filtrate here. And the filtrate contains water, lots of water, sugars, amino acids, vitamins, nitrogenous wastes, all kinds of things. That's what's in the filtrate. Now, a lot of what's in this filtrate are important resources here, especially for a land organism, water. You don't want to lose the water. So a lot of this stuff we're going to take back. We're going to reabsorb. And that's going to be the job of much of the rest of this nephron, is to reabsorb the good stuff and leave the bad stuff, the nitrogenous waste, to exit the body. Remember, anything that stays in this tube is going to exit the body and leave. All right, so we're in Bowman's capsule, and this filtrate is beginning to leave. So the filtrate's going to go in this direction. And as the filtrate goes in this direction, this is the next part of the assembly line, right here. And this is going to be referred to as the proximal convoluted tubule. It's proximal to the renal corpuscle here. And by the way, the renal corpuscle, I'm going to go ahead and write that right here. Renal corpuscle. The renal corpuscle is made up of Bowman's capsule and the glomerulus. So that's the renal corpuscle. So as the filtrate leaves the renal corpuscle, it enters the next part. And that next part is called the proximal convoluted tubule. It's called the proximal convoluted tubule because this tubule is proximal, close to the renal corpuscle. It's convoluted. Now, I didn't draw that here, but convoluted means twisty and windy. In real life, this thing is very twisty and windy. And it's a hollow tubule. Very important part of the assembly line here. What happens here mainly is reabsorption. Reabsorption. Reabsorption of what? Waters, sugars, amino acids, vitamins. All those things get reabsorbed here. And when I'm talking about reabsorb, that means that they leave this tubule and enter the blood vessels that are nearby. That's getting reabsorbed to enter the body again. The nitrogenous wastes are going to stay in here. Now, everything doesn't get reabsorbed right then and there. That's why we got the rest of this tubule. So let's follow the rest of this tubule along here. We've got this big loop here. And this loop dives deep into the kidney. In fact, I'm going to go ahead and I'm going to draw a dotted line here. And this dotted line is going to represent the cortical medullary junction. So above it is going to be the cortex, and below it is going to be the medulla. And this is the cortical medullary junction, where most of these nephrons are found. And this tubule goes deep into this cortical medullary junction. And that's going to be very important in just a minute. Let's talk about that. All right, let's go ahead and name this. This is the loop of Henle, named after Mr. Henle, who did some work on this. Now, it's got two parts. It's got a descending part, descending loop of Henle, and an ascending part, an ascending loop of Henle. And they perform different jobs. Let's talk about the ascending loop first. So I'm going to go over here and talk about it. So the ascending loop there's the ascending loop of Henle, and its job is to reabsorb salt, in this case sodium chloride. So let's go ahead and draw that. So I'm going to draw sodium chloride coming out, and a lot of it is actively transported out of the tubule and into the nearby tissue. I know, let's go ahead and draw, there's sodium, Na plus, Cl minus, Na plus, Cl minus, Na plus, Cl minus. And so much sodium chloride is coming out, some of it gets reabsorbed into the blood again, and a lot of it just kind of hangs around this whole area. Now I know it looks like a lot of distance from here to here, but really not too much distance. In fact, there's so much sodium chloride around here that there's going to be sodium chloride just about everywhere here. So I'm going to write this down. Na plus Cl minus, Na plus Cl minus, loaded with a lot of salt through here. Here again, Na plus Cl minus, Na plus Cl minus, lots of salt. And in fact, if we draw an arrow here, and this arrow represents a concentration gradient, we're going to have increasing NaCl. Increasing salt concentration as we go deeper into the center of the kidney, or the medulla. And this is very important because as we go deeper into this medulla, all this salt allows us to concentrate the urine. That means it allows us to pull lots of water out of the urine, because we don't want to lose that water. The most important resource for any land animal is water. We don't want to lose that water. Now, that's what this does right here. We're going to actively transport sodium chloride out of the tubule into the nearby capillaries and nearby tissues. And we're creating a very hypertonic environment, a very high salt concentration. Now let's go back over to the descending loop. So I'm going to go ahead and label that. This is going to be the descending loop of Henle. And its job is going to be to reabsorb water. So I'm going to show water coming out here. H2O, let's go ahead and label that. So we're going to have a lot of arrows here. So water, water, water's coming out. Now water's coming out of this tubule because this tubule is permeable to water, meaning it allows water to leave, but it does not allow salt to exit. Only water. That's very different from over here. Over here, salt is allowed to leave, but water is not. And that's going to be very important. So we got lots of water coming out of here, and the water's leaving because of osmosis. Water wants to go from where there's low solute to where there's lots of solute. In this case, lots of sodium chloride. So this is going to allow us to reabsorb lots of water and concentrate our urine. Now let's move on to the next part of the assembly line here. And this next part is going to be referred to as the distal convoluted tubule. And again, it's distal, distance, because it's further away from the renal corpuscle than the proximal convoluted tubule. And again, it's very twisty and windy, but it's not drawn that way, all right, for simplicity. Now this distal convoluted tubule, really important. What does it do? It does a couple different things. One, reabsorption. Okay, going to be similar to the proximal convoluted tubule. Okay, so it's also going to reabsorb some water, some amino acids, vitamins, sugars, things like that. But in addition to that, it's also going to function in secretion. Okay, and secrete is the opposite of reabsorb. All right, when we reabsorb something, we take something from the tubule and put it into the blood. When we secrete, we get rid of. So we're taking something from the blood and putting it into the tubule. Now, what exactly are we secreting? Well, we're going to secrete hydrogen ions, and we're going to secrete potassium ions. So these things are going to end up in the distal convoluted tubule. Now, this is important. We want to secrete hydrogen ions because a lot of times the body has a tendency to become acidic. And hydrogen ions are the acid part of an acid. So if we get rid of hydrogen ions, that's going to make us more basic. That's going to drive up our pH. That's a good thing. In potassium ions, we're going to get rid of those. And we're going to talk about that right now, in fact. The next thing that distal convoluted tubule does is this is where the mineralocorticoids are going to exert their action. So let me go ahead and write that down. Mineralocorticoids. All right, mineral meaning minerals. What minerals are we talking about? We're talking about sodium and we're talking about potassium. Cortico, this has to do with the adrenal cortex. That's where this is actually made. The adrenal cortex. And it's a steroid hormone. This is where it exerts its action right here. So when the adrenal cortex releases mineralocorticoids, this hormone acts right here, and what it does is it causes sodium to be reabsorbed into the blood, so we'll do that, and potassium to be secreted into the tubule. So we're going to trade a positive ion for a positive ion. Now, sodium is really important. Sodium is very osmotically active. Water likes to follow sodium. So mineralocorticoids are going to be very important in maintaining our long-term baseline blood pressure. All right? So as we reabsorb sodium into our blood, the water is going to follow. And if you have more water in your blood, that's going to increase the blood volume. If you increase the blood volume, then the blood's going to push harder on the walls of your blood vessels, and you're going to have higher blood pressure. Right? That's a good thing, but you don't want it too high. And that's what mineralocorticoids are going to do. Now, the filtrate, after it goes through here, is going to go into the last part of our nephron, and this is going to be referred to as the collecting duct. It's called a collecting duct because a lot of the nephrons are going to empty into this collecting duct. But it's an important part of the kidney because it also does an important task. Its job is to fine-tune water. Okay, fine-tune the amount of water that remains in the body or leaves the body. And it does this through the action of ADH. ADH stands for Antidiuretic Hormone. Now this ADH is going to be produced by the hypothalamus. It's going to be stored in the posterior pituitary and then released there. Once it is released from the posterior pituitary, it exerts its action on this collecting duct. If you have more antidiuretic hormone, more ADH, you are going to retain water. Your body's going to hold on to that water. So during times of intense exercise, when you're sweating a lot, you don't want to lose excess water through urination. So your body's going to produce more ADH to retain that water. During times of low ADH, right, we're going to lose water. Now, when is the ADH going to be low? Well, if you just drank a quart of water, a bottle of water, then you got more water really than what you need probably. So that's going to cause the ADH levels in your blood to go down so that you lose that excess water. And an interesting thing here is that alcohol, whether it be from beer, wine, whiskey, whatever, alcohol is going to inhibit the release of this ADH hormone, which is why when you drink alcohol, the floodgates open up. If you don't produce this ADH, you're going to lose lots of water. And you end up with that cotton mouth the next morning because you've lost a ton of water the previous evening. Not good. From here, the filtrate then gets collected in the ureter and then goes to the urinary bladder and finally to the urethra and out the body. And that's going to be it for the nephron.